So we're given the coordinates of a point P, that's 3, 4, and the coordinates of a point Q, that's AB. Right. We're also given a line perpendicular to PQ and its equation, which is 3x plus 2y equals 7. Okay, let's just think about what that means. If it's perpendicular to PQ, well, we know something about perpendicular lines. Look at the second blue box down here. We know that perpendicular gradients multiply to give -1. So I expect we're going to have to use that. Now, what's next? It asks me to find an expression for B in terms of A. Right. Okay, well, as I say, this is a question about gradients. So what we're going to need to do is we're going to need to find the gradient of PQ using those, and the gradient of this line using perhaps the equation of a straight line, and then multiply them together to get -1. And let's see what happens. Okay, so let's start at the beginning and go with the gradient of PQ. Well, how do I find a gradient when I have coordinates of points like this? Well, let's look down here at my third blue box. And yeah, the old rise over run still works. But in order to get to the rise in the run, what we need to do is we need to find the difference in the y coordinates and divide by the difference in the x coordinates. And you'll notice down here, I've said in very formally for 2 points, x1, y1 and x2, y2. Well, that's these 2 points here. And as long as we subtract the right way round, as it were, so we always do the second one minus the first one, we'll be absolutely fine. So let's do that. So y2 minus y1, well, where are they? These are the y coordinates, so the second one minus the first one is b minus 4. And then we do the same for the x coordinates, a minus 3 on the bottom, and that is the gradient of PQ, which we'll use in a minute. Okay, so let's leave that there. Now let's find the other gradient. Let's use the information we're given here and rearrange the equation of this line to see if we can find its gradient. Now what am I going to rearrange it into? Well, as I pointed out earlier, we're going to use y equals mx plus c, because as soon as we've got it in that form, we can just read off the gradient. It's the number in front of the x. So let's do it. So we want to get y equals, so let's subtract 3x from both sides, and that gives me 2y equals minus 3x plus 7, trying to make it look like this, so I'll put the x before the 7. And then I need to get y on its own, so I'm going to divide by 2, and I have to divide everything by 2. So like that. The 2's on the left cancel, that was rather the point of dividing by 2, and I get y equals minus 3 over 2 times x plus 7 over 2. And now I can see that the gradient of this line here, and so m, as it were, the gradient of that line is minus 3 over 2. So what does that mean that the gradient of PQ is? Well, so the gradient of PQ times minus 3 over 2 must equal -1. Why is that the case? Because of this blue box here. And, well, I hope you can see exactly what it is we need to multiply by, or to get -1, without really doing any working. What times 3 over 2 is 1? Well, 2 over 3, and there's already a minus sign. So the gradient of PQ is 2 over 3. And then all I do is I put the thing we found earlier, which was an expression for P over Q, or the gradient of P over Q, into that and make it equal. Okay, so we say, so B minus 4 over A minus 3 is equal to 2 over 3. And now I just want to get B equals. Right, how do I sort this out? Well, the golden rule is to get rid of fractions first. And so I multiply both sides by whatever's on the bottom. First of all 3, and then A minus 3. Okay, so I'm going to do 3 times A minus 3 times both sides like that. And with the green cancelling pen, on the left, the A minus 3's cancel, and on the right, the 3's cancel. And so if I write that out a little bit more clearly, just to make life easier, 3 times b minus 4 is equal to what's left on the right is just 2 times a minus 3. And we're nearly there. Let's multiply out the brackets. 3 times b and 3 times minus 4 gives me 3b minus 12. Multiply out the brackets on the right. I don't necessarily need to multiply these ones out, but I'm going to because we normally do. 2 times a and 2 times minus 3 gives me 2a minus 6. And now to get the b on its own, a couple of things to do. Add the 12 to both sides, which gives me 3b on the left and 2a plus 6 on the right, and then simply divide by 3 to get the b on its own. The 3's cancel on the left, and I get b equals 2a plus 6 all over 3. And we're there. Okay, so just go back and remind yourselves of the theory we've used, and if it's not clear already, it will be then.